can see folks are starting to join. We're going to give it just a minute. I'm just going to wait a minute for folks to come in from the waiting room, and then we will get started.
Sounds good.
Right, we are going to go ahead and get started because we are a minute past our start time. So I want to welcome everyone to this Linux Foundation Energy webinar on GridChat, leveraging GenAI for smarter power distribution modeling with Arras Energy. We're joined today by two fantastic speakers, David Chassin and Pedro Youngiri. I'm going to let them introduce themselves. But before we do that, I will note that if folks have questions, please use the Q&A tool in the bottom of the Zoom interface. You can submit written questions there, and then after the presentation has been completed, we will go ahead and answer those in the order that they were received. So with that, I will hand it off, and we'll get started.
Awesome. Thank you so much, Dan. Can you hear me well?
Yes.
Perfect, perfect. Good morning, everyone, or good afternoon, everyone, depending where you are. I'm Pedram Jahangiri, a solution architect at AWS, and I should say a proud member of Arras Energy Technical Steering Committee under Linux Foundation Energy. So a little bit background about myself. I have PhD in electrical engineering, and over the years, I worked on power system modeling and AI, both during my PhD studies and in roles like companies like National Grid and AWS. Today, I'm really excited to be here to talk about how we are using generative AI, that small thing that you've heard about, with GridChat to make power distribution modeling better and more efficient. But before we dive into GridChat, I want to introduce my co-presenter, David Chassin. David is a true expert in this field. He is one of the main founder of GridLAB-D, basically a father of GridLAB-D, and he'll walk us through Arras Energy, how it's driving innovation in energy system with GridLAB-D. After David, I'll take over to share more about GridChat and how it works and how it can impact, basically make an impact. So David, over to you, please.
Thanks, Pedram. Yes, hi everybody, and hope everybody's having a good day. My name is David Chassin, and yes, I was one of the lead developers, in fact, a PI for the U.S. Department of Energy's GridLAB-D project when it was started about 20 years ago. And so I've been involved in the development of GridLAB-D since then. My background is mechanical engineering. I have a PhD in mechanical engineering, but I've done a lot of work at the junction between mechanical engineering and electrical engineering, which is where the simulator sits. And I work for the U.S. Department of Energy's National Laboratories for nearly 32 years, I think yeah, it's about right, 32 years. And I recently retired, and now I'm doing my own consulting company, basically continuing to work on GridLAB-D. I also chair the steering committee for Arras Energy, which is built on top of GridLAB-D. And so with that, I think, Pedram, we can proceed. So what I'm going to talk about first is just a history of Arras Energy and GridLAB-D. These two are essentially, you have to think about Arras Energy as the commercial version of an enhanced version of GridLAB-D that was developed by the state of California. The California Energy Commission funded an effort to take the U.S. Department of Energy's version of GridLAB-D, which is essentially a research tool, and make a more commercially viable version that could be used by utilities. So it has a significant number of extensions to the DOE version that were designed to meet the use cases that were identified in the state of California: hosting capacity analysis, some extreme event resilience analysis, deep electrification, and modern tariff design analysis. So these these use cases really drove the development of this high performance version of GridLAB-D called high-pass GridLAB-D that eventually became Arras Energy, which is now being curated and managed by LF Energy and the team of people who belong to the steering committee now. I just want to mention the steering committee and Arras Energy team is open, so if anybody's interested in joining that group and participating in the development of Arras Energy, you can reach out to LF Energy. There's a number of ways that you can join different activities there. There's a lot of different projects, so it's very interesting for people who want to be part of the open source development efforts on grid modeling tools and other things related to energy systems. You want to go on to the next one? Thanks. So let me just give you a quick timeline so you have a sense of the history of Arras Energy and where it came from. So more than 20 years ago, Pacific Northwest National Laboratory, which is the Department of Energy National Lab operated by Battelle Memorial Institute, created a tool that was the precursor to GridLAB-D. And the idea was to create an agent-based solver for various kinds of emerging grid use cases at the time. It wasn't super clear what was going to be developed for the new grid, but we knew it wasn't going to be what the simulators at the time could model. So the idea was we needed a simulator that was forward-looking, that would allow us to explore new technologies in silico rather than go straight to pilot demonstrations in the field. And so DOE picked up this idea and funded the development of GridLAB-D starting in 2007. And that was the EC funding high-pass GridLAB-D, which was as I said, the high-performance version that was ultimately to become LF Energy's Arras Energy project. So that gives you a sense of sort of the overall history. So a lot of credit goes to DOE and the California Energy Commission for making major investments in these tools. It's hard to put a number on how much money has been spent on developing these tools, but a lot of capabilities emerged because of that. So I'm just going to go over quickly the kinds of solvers that are present in the tool now. The focus was primarily on distribution system solvers. And the reason is because a lot of the emerging technology that DOE was interested in exploring related to distributed generation and distributed energy resources. And because these were found primarily in the distribution system, we needed solvers that could handle distribution system, very complex distribution systems with a lot of different features, different technologies being deployed that didn't exist in the solvers that were available at the time. So the distribution system solver has a three-phase unbalanced solver. It uses a Newton-Raphson current injection method. There are a number of other methods available there, but they're not widely used. They're sort of for special cases, either highly radial systems where Kirsting's method is particularly effective, or if you want to study things like motor stalling behavior and transient dynamics, there are some capabilities available to do that. And then of course there are converters to convert from widely used simulation models that you find among utilities, particularly in California, where a lot of these are being tested. There's also a lot of very detailed asset modeling included. And this is why, and we'll talk about this a little bit more, why a tool like GridChat is going to be so important. There's a lot of complexity, a lot of detail that has to be provided, and it can be very tricky to put together these models in a way that makes them work correctly. But these asset models allow us to do very interesting analyses, particularly when we get into things like resilience analysis, when we're interested in how extreme weather events might affect the infrastructure, and so on. The load models, sorry, Pedro, I'm going to stick to some of this. The load models are very detailed, or it can be very detailed. And again, this is why GridChat is going to be so useful to us, because there's a lot that you can set. And then there are a lot of other features that GridChat can help you deal with. We're not going to go over these examples, but there's a positive sequence solver that's based on PyPower. There's a lot of aggregated asset models that are used to do transmission modeling. And then, of course, there's geodata. So when you're doing very large models over large geographic areas, you can get very complex weather patterns and load shapes and all sorts of data that varies regionally. And that is dealt with these types of solvers. Okay, ready to move on now. And then I'll just quickly mention some other modules that are useful. There's modules to model human behavior that are being developed now, and we're looking for contributors to help us with those. We have modules that come from extensive work that was done at DOE for connecting to hardware in the loop and other kinds of simulators that need to be run co-simulation. Those are not necessarily supported directly by Arras Energy, but they are supported in the experimental versions that DOE develops at PNNL. And then, of course, the modules that relate to resilience and revenue analysis and tariff. And there's even a module that does things related to transactive energy. And of course, all the database interfaces and so on, optimization tools that you would expect to find in a tool like this. Next. There are also a lot of subcommands that are used to help you manage your GridLAB-D environment and prepare data for use in GridLAB-D. Things related to generating building models and converting data and manipulating geographic data and asset libraries and so on. And you can see the list of all of these here. These are all also included in what GridChat will be able to draw from when it tries to respond to questions. And next. And last, here's an example, of weather data, and that is available through the weather command. Sorry, I didn't mean to. And finally, there's a lot of tools that are used to actually create fragments of GLM files that you use to compose a model. So things like creating duct banks and filters and connecting meters to load or between loads and service transformers and populating poles on a model and so on and so forth. So you can see there's a lot of things related to resilience and particularly fire danger, which, as you might imagine, is becoming more and more of an issue. Constructing filters that are used to connect properties of different objects together, grouping things, market data for wholesale markets, for example, and weather data. I think that's about it. Do you want to go to the next slide? I wanted to mention there's extensive support for Python integration. And again, this is the GridChat has access to all of this documentation and examples of how to do this. Can get quite complex. And one caveat is, if you're using a tool like the code generators that you find in, the AI assistants that generate Python code for you, they may not work as well with these kinds of models because they would not draw on the kinds of things that GridChat would draw on. But the Python integration allows you to manipulate the models and alter them and integrate other tools with GridLAB-D simulations while the simulation is running. Next. So here's the documentation that GridChat draws on. There's about 1,000 pages of documentation for Arras Energy and GridLAB-D, and this is the primary source for GridChat's knowledge base. Next. And there are user interfaces for Arras Energy. You can, of course, just create GitHub projects and just run GridLAB-D in the actions in GitHub. OpenFido was a tool developed by CEC to put together large complex workflows that need high reproducibility, something which can be challenging with a lot of tools like Jupyter Notebooks and so on. Marimo notebook integration. For those of you who don't know, you can think of Marimo as a Jupyter notebook that is stateful. It knows and remembers the states of things so you don't get these reproducibility problems that you find with Jupyter notebooks. And there's an integration in GridLAB-D for Marimo notebooks, which gives you very, very powerful user interface tools in your notebook. And then Hitachi has developed a complete front end for Arras Energy and GridLAB-D, and of course that gives you a comprehensive tool to build models and run simulations. Next. All right, so back to you, Pedram.
So, thanks so much, David. Really appreciate that. So, so just think about it. We all know GridLAB-D is incredibly power tool, basically for modeling distribution system. Some of you might have used that, but some you just heard about it. But this is a powerful tool. I have used it actually a lot when I was doing modeling in National Grid. But if we face it, it has its own unique syntax. It's really challenging, even for power user, experienced users. I remember when I was actually working at National Grid and modeling real feeders in the state of New York and state of Massachusetts. Whenever I ran into issue, I had to reach out to folks at Pacific Northwest National Lab or post my question in a forum and then wait, sometimes for days, and for just one response. It was frustrating and it was really slow things down. But fast forward today, when I saw the incredible progress in GenAI and natural language processing, I started thinking, and we started thinking, me and Dave, what if we could build just a smart companion that helps users like us with GridLAB-D modeling? And so that's how GridChat idea was born. And basically, GridChat is like having an assistant built right into this tool that you will see. It makes using GridLAB-D easier by letting you ask question and then get answer in natural language. And also, if you are stuck with syntax problem, trying to debug a model, or need just a quick context for your work, it is by design, it is designed actually to save time and simplify those tough tasks. So I was thinking what would be beneficial for this audience, and I said, okay, let's think about, let's see how, before I show GridChat to you, go behind the scene and see how basically it works, basically the technology behind GridChat. So it might be also inspiring for you to actually join the development or enhance basically it, or it might be inspiring for you to build your own basically tool similar to GridChat. So GridChat is using the power of these large language models or LLMs, which I'm sure many of you have heard about. But there are two big challenges by using LLMs or large language models directly. First, they have a knowledge cutoff. All of them, they have been trained up to the certain point. So that means they only know things up to a certain time. So they might miss new information. The second one is sometimes they hallucinate. Basically, they might confidently give you the wrong answer. So to fix these two problems, GridChat try to combine the reasoning power of LLM with semantic search from an up-to-date knowledge base, the one that just Dave actually referred. And with this ensures that the answer you get are not basically are not just accurate, but also current and also reliable. So a little bit background. Let me talk about different ways that we can use and customize these large language model. I was thinking this might be, some of you might know, some of you this might be new. It's like a quick 101 on the techniques that we could use. So in order to making these GenAI tools really useful, it means that you have to choose the right approach for our needs. At one end that you see here, there is prompt engineering. Basically, simple tweak you can make quickly and make it work for your to provide the right answer to you. On the other hand, you've got continued pre-training, which is basically training a large language model specifically from scratch for a specific task. This involves a lot of time and basically effort and money. But in between, if for a specific use case, we have options like fine tuning, basically a bit change on the basically the large language model, the models, those basically weights, or using a mechanism that is called retrieval augmented generation, or RAG. Uh, Basically, RAG is it combines the reasoning capability of LLMs uh, with accurate, up-to-date information from a knowledge base. And this is what we are going to actually dive in and on the next slide. And basically, GridChat is using RAG mechanism. So this is the architecture of GridChat. And I'm gonna talk how RAG basically works in GridChat. It's actually pretty simple when you break it down. So first, a user starts by asking a question or making a request. Then GridChat use basically a special large language model. It's called embedding LLM to process that question and convert that to a vector. And then it does basically, it passes it to a knowledge base, and it does the searches, it does the semantic search in a knowledge base. In this case, our knowledge base is powered by Amazon OpenSearch, or basically this is similar to Elasticsearch, to find the most relevant information. The search pulls up related documents, like data from GridLAB-D resources in this case. Next, this information is combined with the original question and sent to another large language model. In this case, we are using basically a model called Cloud by company Anthropic, and we basically we are using AWS Bedrock service. And don't worry, we are going to talk about AWS Bedrock. Finally, this model uses both the question and the context to generate a clear and accurate answer. To just reiterate, this approach makes sure that we are using the reasoning power of LLM while also bringing the most relevant and up-to-date information. It avoids basically outdated knowledge and also the possible hallucination response. I told you that actually we are using Amazon Bedrock or AWS Bedrock for both basically these large language models and the knowledge base. So let's talk a little bit about Bedrock and why Amazon Bedrock is basically such a big deal. Without Bedrock, we'd be stuck managing these large language models and setting up servers, hosting the models, and dealing with all these behind-the-scene technical works that are not basically our focus. So that's a lot to handle. But Bedrock changed all of that for us. It's fully managed service that make it simple to use these GenAI models. And especially in today's fast-moving GenAI world, when new model basically pops up almost every day. I'm sure you have all heard about the buzz around DeepSeek, which is actually a very powerful model as well. So Bedrock gives you the flexibility to keep up, and it connects to the top models from AI21 Labs, Anthropic, Cohere, Meta, Stability AI, and Amazon model itself. And even better, if you have your own model, let's say basically you downloaded DeepSeek from Hugging Face, you can bring it into the Bedrock and call it as an API in a serverless way. I just did it actually yesterday, and it works perfectly. So this makes scaling and building application smoother and faster, and it's basically you can switch your models the day that you found a model is better. And when we say better, it means always a trade-off between the cost and the performance. So let me just summarize why we chose basically Bedrock for GridChat. one of them, I just talked about it, model choice. Model choice is really important. So you can pick best foundational model for your specific needs, and you do it all through a single API. The next one is basically customization with tools like fine-tuning and RAG. You can securely adopt these models to your own data. So we're using RAG here. Security and privacy. So your data stays safe and compliant with governance standard, giving you peace of mind. Let's say you are passing a GLM. That GLM, when it actually goes to a model, and the model basically read that and provide the response, this never basically goes to a vendor, and it doesn't use your data. It's not used basically for any retraining. So the data stays in your own account, and this is important. And finally, serverless simplicity. You don't need to worry about managing any infrastructure. It's all taken care of. So you can basically, in our case, you can focus on building and deploying the application, which was GridChat. Another thing, if we take it a step further with knowledge base for Amazon Bedrock, this is something that we used also. In this case, RAG became fully managed process. That means, so basically Bedrock handled everything for us, pulling in our data, finding exactly what's relevant and combining it with user requests to make response smarter. So we didn't need to write like a custom code for managing queries. We just basically referred that to a knowledge base ID into our code. So it is also designed for multi-turn conversation. I'll show that to you. So if a user asks a follow-up question, the app remembers the earlier context. So if there is a chat history, so keeping the interaction smooth and meaningful. And I think the kicker, which is the most important part of the RAG, is every piece of information retrieved is cited. So this builds trust and avoid confusion. So the user can actually look and click on the source and where this response is basically coming from. Before I show you a demo, since we use Anthropic Cloud model for GridChat, so a quick overview about these models. They offer a flexible range of options tailored to different needs. I would say balancing intelligence, speed, and cost. GridChat leveraging basically Anthropic Cloud model, particularly Cloud 3.5 Sonnet. In my opinion, and what I have actually done, it does a complex reasoning, and the performance is really good. And these models, I think, ensure high quality performance. We can actually, as I mentioned, if a better model comes, we have the ability to switch to the other model. Okay, let's actually show you a quick demo on how GridChat basically works. So today, GridChat is getting served at this domain, gridchat.gridlab-d.us, and you have the ability to go and sign up for that, and you can actually try it on your own. And yeah, let me actually, so I'm gonna show you three use cases. Basically a simple question as a conversation. Then I'm gonna go to another use case, which is, I would say, a troubleshooting type of use case. And the last one is we're asking for us to generate basically a GLM file, and I'm gonna actually running on a machine that actually running GridLAB-D to see if it can actually run that GLM. So let me go to my browser, and here is GridChat. So I have already signed in. So the first question that I'm gonna ask is just a conversation. So let me copy paste from here, and I'm asking if So explain the role of the clock objects in GridLAB-D. Can you also provide a working example for a simulation starting at 8 a.m. on January 1st? And let's see. So I'm not gonna read everything, but I want to show you how the response is. I mean, in my opinion, it was very powerful response, and I have tested on those basically, let's say, DeepSeek or Grid or ChatGPT or others. The response is not as accurate as here. Basically, the clock object in GridLAB-D manages time in simulation, controlling the simulation's time zone, start time and stop time. It's crucial for coordinating object state changes and determining the simulation's duration. And it does provide some details, and it actually gives you a working example for simulation starting at 8 a.m. on January 1st. And for those of you that you know the syntax of GridLAB-D and how picky the GridLAB-D engine is, that if the syntax is not working. So this is an accurate basically syntax, and we could actually look open the sources, and in fact this is one of the tutorials of GridLAB-D it's referring to, and the time series and the clock, and you can actually find more information here. So this was the first example. The second example that we were thinking, David and I, we were thinking that it could be actually helpful is this one. If you have like kind of like a use case in a simulation. Let's say my simulation results show abnormal voltage swing at node 12. What could be causing this? And how do I debug this issue? Then you hit actually run, and then it will give you information. Something I liked about this is that if you read, it says abnormal voltage swing at a specific node can be caused by various factors. To debug this issue, we need to investigate the model setup, load characteristic, and nearby components. I'll provide a step-by-step approach to identify and resolve the problem. So first, it says about possible cause of these: incorrect load modeling, improper transformer setting, unbalanced phases, that's a problem, and nearby distributed generation sources, like if you have a PV close to that, or faulty voltage regulators and capacitor banks. And believe me, these are all things that I have seen actually in practice when I was doing the modeling. And it gives you debugging steps: verify model setup, analyze load characteristic, and in fact, it's telling you to a GLM snippet basically to see if you can actually provide a recorder, and you can ask more questions, and it's looking for some other information. So this is another example use case, and the last one, I like this one as well, because in my opinion, when I tested, none of them just basically off the shelf type of tool could provide this. This is basically, I want to say that I want to model a distributed energy system with a photovoltaic array and a battery storage system. Can you generate the correct GLM syntax for it? And let's see what it does provide. So I'll provide a GLM syntax example for modeling a distributed energy system with PV and battery storage system, including necessary modules, objects, and their configuration. And here is the GLM syntax. So this is the GLM. As you see, so this is just generated, and we don't know if it's gonna work or not. So what I'm gonna do, so I'm gonna copy that, and hopefully it works. So I have a machine, I have an Ubuntu machine that actually it has GridLAB-D, and I wanna actually, let's see, I have a test GLM, and let me copy from here and paste it here, save, and see if I can run this, and it will generate basically that. Hopefully I copy paste the right things. So it's giving me an error, cannot initialize the inverter without a parent. So let's see, hopefully it can actually fix this. So let's say the error message indicates that there is an issue with inverter object initialization, specifically related to its parent correction. I'll provide a correct GLM syntax. So let me see, can you provide full GLM? And this exercise is helpful because actually I'm gonna show that to you what is our future plan and what we are actually planning to do as we are going through a loop before I actually provide the GLM. Right now it's just GLM and we have to manually test it. So let me copy paste that. So it gives us the ability to talk and find out basically the issue. So I think there is still an issue here. David, are you able to actually quickly identify the issue, or we can actually move on?
I see the parent. It is specified. I'm not sure why that error is coming up.
So so there is a
Oh,
parent.
there's looks like there's a second inverter. Sorry, the scrolling's jumping for me, so.
Yes. So the idea is basically here is that you have the ability to basically do talk with GridChat and actually be able to find the answer. So right now it's not connected to any basically tool to check and go for the loop. So basically what we are planning to do, and I'm gonna actually go to the next slide. This is our future plan. So basically, by expanding GridChat's capability, we want to actually make sure that GridChat is basically right now it can just generate GLM files, but which is already a big help, and you can talk with that. You saw that we just had an error, and you were able to actually find an error with just some go back and forth. But we are aiming higher in future. We want GridChat not only basically generate GLM, but it also connect to the GridLAB-D engine. So basically, we go through a loop when a GLM is created. It's like an agent. That agent basically has access to the tools like GridLAB-D engine, so it can automatically check for any syntax or topological error and make sure basically everything is good before it passing to the user. And also we want to work toward having GridChat handle post-processing tasks like creating visual graphs or detailed reports from simulation results. And so the idea is just to help users get insight faster and also making sure that the GLM is working. And yeah, that's it. And just basically last but not least, before we go to the questions, I think as you mentioned, as you saw, it's not perfect yet. So we are actively seeking input from the community. Please go ahead and sign up and use that. And also, if you have any feedback or interested, like what Dave mentioned, in joining to Arras Energy and helping us to improve, we'd love to hear from you. And I think this is what I had. So I would love to actually see if we can, Dave, if we can go and take some questions.
There are some in the interface.
Okay, so let me see. Thank you for. Do you so I just see actually the question from you. Can you is there anything that
Yeah,
Dan you can
that's in
actually
the chat. There's a button that says Q&A. If you can't see it, I can read them out to you though.
let me
There's
see.
several questions now.
Let me stop sharing here. And okay, now I see the Q&A. So for GLM syntax, are you using RAG or Sonnet model out of box? Has GLM syntax knowledge as it may have been trained or most open source material? So we are for GLM syntax, we are using RAG. So this is something that we are using RAG. So we have we have instructed our model Sonnet and also for any question before it goes to the LLM directly, as I mentioned, it is actually going to our knowledge base, and our knowledge base has basically the connected to the tutorials, all the most up-to-date GLM examples, and it's using basically those GLM snippet, and then it brings as a context and combines it and send it to the Cloud Sonnet for final response. So to answer your question, it it does use the power of the sonnet for regenerating the GLM syntax, but for the formatting and everything else, it used the knowledge base. I see the second question. How can we extend this approach to other power simulations? What would be required to facilitate this process? That's a great question. So I would say as I mentioned, it would be super straightforward. We just need basically the architecture that I showed you, and we will have this presentation uploaded the video in a YouTube, and Linux Foundation Energy can provide this to you, the link. But the idea is basically using a RAG mechanism. So you can have a knowledge base that is connected to other simulation, let's say PSSC, and you can actually leverage the same mechanism and actually build an application for the other simulators. How have you evaluated the quality of response? That's another good question. So I would say just two of us so far and some technical steering committee, they have basically asked question and did some common sense, and actually actually Dave actually had reviewed, and so far to Dave's standards it's good. So that would be actually I would say a good evaluation, but we haven't done a systematic evaluation. I would say the systematic evaluation, especially for GLM syntax, because other type of questions, always refer to the document, and I can say it's very robust if you have any question about GridLAB-D itself. But generating GLM, I would say the systematic approach is that we pass the generated GLM to a GridLAB-D engine and making sure that it can run basically the simulation with no error. That would be the best type of evaluation. And Dave, go.
Yeah, so I think with respect to the three use cases that Pedram demonstrated, the first one, I think the answer was spot on. I had no concerns about the answer. And the second one, I had one concern, and I think it relates to how these engines typically work. It did not offer what I thought were potentially some useful avenues for debugging. For example, it did not suggest doing a voltage or a current dump. which is one strategy that is often used for the kind of situation that's there. And I think the reason that happened is nowhere in the documentation does it talk about voltage and current dump as a strategy for solving this kind of problem. So it really couldn't come up with that from whole cloth. And so I think that's one thing that is often challenging in evaluating the quality of these responses is what's missing, right? It's a lot easier to find when it makes a false statement, but something that it should have said that didn't is a little bit trickier and takes a lot more experience with these kinds of questions. And then with respect to the third one, I have to say that's the first time in all of our experimentation that it generated a GLM that didn't work and that it couldn't figure out how to fix. Pedro and I had repeatedly tried this and it worked every time. So,
Yes.
my only thought, and I don't know if these LLMs still work the way the original ChatGPT worked, would be to turn the temperature down on the model so that it generates answers that are more consistent but less imaginative, or less, creative, I guess I would say. So that's kind of my thoughts about evaluating the quality. I don't think there's any way to avoid having expertise in reviewing the quality of the responses, except with perhaps this agentic approach where the response, if it's a GLM, is run through the simulator first before it's delivered. The main downside with that is, for most of you who've used these, that it generates the text as it goes. When it's running in a scenario where you have to take the entire text and submit it to a simulator to test it, you can't do that unless you have it generated and then ask a question like, do you want me to test this for you, or something like that.
Yes, exactly. And let me read the other question. Let's see. Could GridChat be used to automate orchestrate simulation for AI training? Let me see. So as I mentioned, GridChat could be used to automate and orchestrate simulation. This is something that can be done. Again, the explanation of an agent, if you can think about it, right now the chatbot like GridChat, it does only connect to a knowledge base and it provides an answer, but it cannot do any action. If we want to convert GridChat to an agent, that means that agent or a software, basically, it can basically first, when the question comes, it has the ability to split and understand that query. And if it needs any action, it does have access to different tools. The tools could be, in this case, a simulation. So basically, the GridChat, we can convert that to an agent to understand the task and split it in different tasks, and then generate GLM and pass it to a simulation and run the simulation. We could design, I don't know exactly what's the AI training here means, but if you mean that GridChat or any other tool generates synthetic data for different type of simulations, and then with that you could actually provide right GLM and right basically power flow results for a specific AI training, yes, it's possible, but it has to be converted to an agent. And I'd be happy if you want to actually just basically elaborate here in the chat, or you can connect with me separate in LinkedIn or other avenues. And let me see, there is another question. Could you please briefly re-explain in simple terms to a beginner of the GenAI world the main component, logical step you use to build GridChat, combining LLMs and Amazon Bedrock? Yes, of course. And it might be actually better if I share my screen again, and I can actually briefly tell you about that. So think about it. We have one option here to just send a question or query directly to a large language model. One of the components of large language of GenAI is these large language models that they have been trained on a large corpus of data, and um, and they have knowledge and they have reasoning capabilities. But here, we don't want to use the knowledge that is basically embedded in these models. We just want to use their reasoning capabilities. And we explained why we don't want to use their knowledge, because all of them, they have knowledge cutoff issue. They have been trained up to a certain time. Second, they hallucinate. They have been trained on different domains and they know very well, but sometimes they respond confidently, a wrong response basically. So we want to avoid that. So instead of actually a user directly ask a question, which this question goes to this large language model that is hosted in AWS Bedrock. Think about Bedrock as like a managed system that has many large language model hosted that, and you can use it as an API. So instead of we go directly and ask a question to a large language model, we say the question first goes to our knowledge base. And knowledge base, you can think about a database, a special database that is vectorized. Basically, those natural language has been converted to embedding or vectors, numbers, because computer can work with numbers. And then basically when a question comes, it does search into the knowledge base and find the relevant context, semantic search. And when the context comes up, in this case, it might be the snippet of GLM or some information about GridLAB-D, then this context documents plus the original question, it will be passed to the large language model, and we ask large language model, don't use your own knowledge, just use your reasoning capability and generate a response based on this query plus this context that we are giving to you, and we know this is an accurate context because this is our knowledge base that we take care of, that GridLAB-D documents, and generate a response for us. And this is how it's generated, basically. Um, yeah, just a suggestion, maybe paste the error that you were getting to the GridChat and ask it to update the GLM response. I think this is what I had done that, but it might actually need some more tweaking. And yeah, of course, yeah, this is something I think I did that. So we need to actually do more testing. I think this is exactly what I did. And let me try one more time, see if it can. It is able to understand that, but hopefully it can provide that. But as I mentioned, it's not perfect. It's basically still, it needs improvement. So the main issue appears to relate to the initialization of the inverter object and possibly some command line or environment problem. I provide the revised GLM file. And
Pedram, you might want to paste the entire output
yes.
because I think it mentioned something about a property that's not valid.
Yes, so let me actually.
You see the line 75 property discharge rate?
Yes. In fact, it might be actually related to these recorders. And let me see if I can remove this recorder and see if it's actually.
So see before the fatal error, it says test GLM 79. It has a problem with the discharge rate property being specified.
Oh, okay.
And I don't know why it has a problem with it, but yeah, same thing with charge rate. And again, I can't explain why it has a problem with those.
yeah, it might be also my GridLAB-D engine, so that might be also a problem. Yeah, to me also the GLM file is actually looking
Delete,
valid.
delete line 79.
Line 79. Oh, charge
It's,
rate. Okay.
it shouldn't be a problem, but
Let me see there. Yeah, perfect. So apparently that was a problem with that property. So it
I
was
think the issue is when you pasted the error, you didn't paste the part of the error message
oh
in.
that part, yeah.
Yeah, so it had never got the right context of the error.
So it was able to generate the PV output, and here is the PV output. You see that all this power, and also I think there was another one meter output, and the meter output is this one. Something when I was really impressed because I had asked some of these basically off-the-shelf model GenAI applications, and they were not able to generate basically even right recorders. So like meter, it has these properties, and also inverter like power A, power B, power C. So that was how I was surprised. But yeah, so I think it was able to generate, and we need more tweaking basically.
Well,
And
I think it probably would have worked if we had included the entirety of the error, because the issues with the charge rate and discharge rate is those are not batteries, the inverters, those are battery limitations. And
yes,
it probably generated those in the wrong place. And if it had been told that those were an issue, it probably would have fixed it.
yes.
So I'd never seen that before. That's interesting. Just goes
So
to
it
show.
might be, yeah. And I think those were right properties, but I don't know why GridLAB was picking on those. Yeah.
Yeah.
Also, let me see if there is. Oh, and thank you for this suggestion. So I think that actually helped, and I think we were able to actually generate response. Let's see. Any more question?
No more currently, and we're just about at time.
Oh, let me actually put here this one. So if you have any more question, we'd be happy to get connected to you through LinkedIn, and yeah, feel free to actually scan these QR codes for myself and David and get connected.
And if you're interested in working with the technical steering committee, you can reach out to LF Energy and get an invitation to join the meeting. They're open meetings, and we usually plan out the projects and the work like this that we're working on.
Wonderful. Well, thanks everyone so much for joining. This webinar, once Zoom has finished processing it, we will, as mentioned, upload that to YouTube. It will also be added to the exact same page where you registered to attend the webinar. And at that point, we will send an email out with a link in case you want to share that with anyone. And we will also include a link to the Arras Energy resources on the LF Energy website so that you can get involved if you would like to. So thank you again to our presenters and to all of our attendees. And I wish everyone a wonderful day.
Thank you.
Everyone.